So let's explore Google's Meridian package, which is an open source MMM tool built by Google, and it has a lot of features like ability to put your videos reach and frequency into the model. You can put in search query volume data, and more importantly, you can also calibrate and make your MMM more accurate using incrementality experiments that you've run in the past. So if you're new to MMM or media mix modeling, it's just a statistical technique that helps us evaluate the impact of various marketing activities on the outcome or revenue of a business. So Meridian is not the only open source MMM tool out there. There's also Facebook's Robin, PyMC's marketing package. There also used to be lightweight MMM, but now Meridian is out. I think Meridian is going to take that place. So it's safe to say that MMM is not new. It's a very old and traditional technique. In the past, we used to use linear regression for these, but nowadays with tools like MMM, they're using Bayesian approach. So traditionally, you would work towards like a point estimate, whereas in this Meridian's case with Bayesian approach, you can see here in the animation that's playing in the background, it gives you like a distribution for your values like high ROAS or return on investment. But that also has a downside because we're using MCMC technique over here in Bayesian methods. It's kind of computationally intensive as well. But more on that a bit later. I want to explore what's happening with this new package and tell you a bit more about it. So if you want to jump in really quick and get started, you can just come into this Get Started tab, and there's a notebook there which you can run through and understand how to use Meridian. But I like to look at all these links over here, which are kind of exciting because if I just click on this, you can see some of the advanced capabilities of Meridian. So it gives us like reach and frequency data, which is often used in ad campaigns. Well, effective ad campaigns, they weren't usually considered within the MMM model or were kind of difficult to incorporate. Whereas with Meridian, if you read through this, it makes it seem like it's kind of easy to integrate reach and frequency, which is really interesting. And then going back again, you can also integrate search, query, and volume. And one other thing that I'm also very curious about is how to integrate previous experiments. So let's say you've done some incrementality or A/B tests or lift tests in the past, and you want to integrate that into your MMM to see how accurate the MMM can be. You can come in here and read through this. There's some examples and ways of incorporating custom ROI priors using past experiments here. So that brings us to a really good point. Why do we even need ROI priors to be integrated into our MMM or prior experiment results? So the thing is, when we are building this MMM model, it's all based on observational data, maybe past 2 years, 3 years worth of data. And all MMM is trying to do is kind of prove out correlation between the revenue and some of these marketing activities. But the thing is, there are various factors that can affect the revenue, like the business might be running a promotion or there might be a holiday or some season. Those are all the kind of confounders that can affect final result that we get out of our MMM. So sometimes if we just leave it at the default MMM setting, then it might overinflate the results or the returns that are attributed to a particular market activity. So to get rid of all these biases, if you have done past experiment, which is like the gold standard, geo-lift test or randomized controlled trials, those kind of things, you can integrate all that into MMM and make it a bit more accurate. And this is especially useful if you're planning to use your MMM to do some budget allocation or optimization for the next coming month. So let's say you build your MMM from the past 2 years worth of data and you want to allocate your budget for the next 3 months. So if you have a more accurate MMM model, you'll be able to optimize your budget a lot better. And as we're talking budget optimization, there is a budget optimizer within Meridian as well, which we can check out. And there is also this really good paper by Google themselves on media mix modeling calibration that came out in 2024 of January. And I encourage you to read through this as well if you're inclined towards understanding the more technical aspect of this calibration. And we'll try and understand more of these concepts as we go along. But for now, let's come into Get Started section. And if you click on it, you'll see a notebook that gets loaded. So you can either just click on this, which will run in Google Colab, which is what we're kind of going to do. But if you just scroll to this, there's a lot of information that you can already see. There's some graphs over here. There's also the final output that we get from the model itself. And also if I scroll to the bottom, you'll also see an optimization scenario where we've been given a recommended budget allocation here. So we'll roughly go through these steps. So what I've done is I've opened up Google Colab in my other tab where it's an empty notebook for now. And if I come back to the sample notebook that we've been given, so there are a few steps like loading the data, configuring and running the model, and generating the 2-page output, and also the budget optimization. So here we have some interesting information. So So within Google Colab, we get access to T4 GPU and one CPU along with it. So even with this, the last time I ran it, it took like 10 to 20 minutes for running this example. So it's interesting to know that even with a GPU, it's kind of intensive. And this goes back to what I said, right? Because we are using this MCMC, Monte Carlo Markov chain simulation kind of thing over here, it is very compute intensive. And that's one thing to keep in mind. But nonetheless, you can still run this for free on Google Colab. So if I come in here and if I just click on this, I can select all these different runtimes. So I've just selected T4 GPU and hit save, and I'm able to connect T4 GPU now. So the first thing we want to do is actually install the library. So you can just paste this command in and then hit this button or shift enter, and then it installs this library into the notebook. And if I come back to my example notebook, you can also see you can install a particular version or install Meridian from GitHub Head as well. So once that is completed, you can just copy and paste this. Again, we are just importing all these libraries. There's no coding happening just yet, but you can see some of the functions that we're importing from Meridian. So functions like optimizer, which is going to be our budget optimizer. There's analyzer, visualizer, and also summarizer over here. So you can just copy all of this and then bring into your notebook. So I can see the previous installation is still happening, but I'll just copy and paste this and hit enter so that it kind of runs right after. So now you might be wondering, what kind of data are we using with this MMM? So here we have a sample data set that Google has generously provided to us. So if I just click on this, you'll see that it opens up a repository with the data that we have. It's a comma separated table. So we have the geo, time, channel, 0 impression, channel 1 impression, and all the way along to the spend channels here as well, and some conversions, promos, population things. So one of the first things that we have to do with Meridian is actually map these columns into a format that Meridian can understand. So that is exactly what we're doing here in this load.cod to columns. So we have a few key columns over here, like the controls, population, KPI, media. These are all like the impression channels, and then we have the actual spend that happened in those channels, and then we have some organic media and also non-media treatments like any promotion that happened. You can even add in the geo as well, but it's typically recommended to do this at least nationally for each of the countries. So in this, we are just setting things up. We haven't loaded our data yet, so I'll just do shift enter and then it runs. So you can leave this as it is, but you can also map these into proper column or channel names. So here channel 0 impression becomes channel 0, and the same thing is also over here as well. It kind of keeps everything clean, at least when it comes to the reporting side of things. And then this is where we actually load the data from Google. So we have the link that we just checked out, and we are saying the KPI type non-revenue coordinates. This is coming from over here up top. Media channel names that we corrected. So this is the correct media channel, media to channel, and then we have the same thing over here, and then data to load. So now that the data is loaded into memory, we can start configuring the model. So here is where some kind of knowledge of statistics or knowledge of how MCMC works is beneficial, but I'll probably make a few more videos on that later on. But for now, we're just going to stick to some of the basic things, like what is this ROI mu and ROI sigma, and what is this log normal distribution, and those kind of things, because it's very interesting to understand all these. But if you don't want to do all that, you can just copy and paste this into the cell and then hit run, and then it'll obviously run because this is in the official example. So what we're doing here is defining the priors. So very simply, what do priors mean? So let's take, for example, TV, and imagine your business has spent $1 on TV ad, and in return you made $1.5. So if we were to plot this, so here's my x-axis, so there is 0, and maybe there's a 1 over here, and then there's a 2. So all we're saying here is I spent $1 and the return I got was $1.5, which means my cursor looks something like this. So it looks something like this over here. Maybe imagine this is my 1.5 and this is the distribution, and then it kind of plateaus. It might not actually go down that much, but it kind of plateaus like this. So this is my distribution, and this is the information that I have based on my historical knowledge, and maybe this is information that's already published out there, and this is the kind of domain expertise knowledge that you can put into the MMM model. And you can do the same for, let's say, Facebook ads, maybe you spend $1, you get some money back, or ROI. You can incorporate all of this into this kind of distribution, and that is exactly what we are doing here with prior distribution. So simply put, prior distribution is like incorporating some expert knowledge or domain expertise into the model. Now we also see this mu and sigma values, and this is used to define the distribution of a log normal. Now if you're wondering what a log normal is, so we have this handy visualization tool that PyMC Marketing have built for us. So you can come in here and look at all types of distribution and see how they actually look like. So for now, I've just selected log normal, and if I scroll down, this is how the distribution is going to look like. So one of the key things why log normal in marketing is because it says the returns were positive. So for every dollar you spend, you made $1.5 via TV ads, for example. So it never goes negative in this case. So it's positive log normal that we're using for this prior. And you can see here, you can change the values. So let me just put in the values that Google has recommended us. So which is mu is 0.2 and sigma is 0.9. So I'll just come in here and put in 0.9 here as well. And you'll see the chart slightly change. So all this means is mu 0.2 is our mean over here, 0.2, and 0.9 sigma is our standard deviation, so 0.9 across. So with these parameters, all you're saying is with mu of 0.2 and sigma of 0.9, your median, which is like exponential of 0.2, is approximately $1.22. So for every dollar you spend with these parameters, you're saying you're making back $1.22. And that is the price that we're defining here. Now, you don't have to stick with the same prior information for all the channel, but here it says in this particular example, the ROI price for all media channels are identical. So we are considering all the channels to be identical, where we spend $1, we make back $1.22. And that is why we're using log normal 0.2 and 0.9 sigma. So this is the next step over here. Once you've defined your prior, you can sample the prior and then sample posterior. And this is where the actual modeling happens. So you can see here in this example, they took like 13 minutes. So let's just copy this and then go over to our notebook, and actually let's paste the priors first. So I'll just run through this and I'll copy the actual modeling as well, and I paste this over here and let it do its thing. So when you have this percentage time, it kind of gives you like an estimate of how long it's taking. So if I just slightly reduce the size of my window, you can see here it kind of is running, and then it populates how long it takes over here. And then finally, it will also populate the CPU time and the user time that over here as well. So it took about 14.5 minutes for this modeling to complete on a T4 machine. So after this, we can print out our diagnostics using these two commands, which are again available in the sample notebook. And you will see a chart like this. Now, how do you make sense of this chart? So here we are looking at our hat convergence diagnostics. So if you remember, we are using MCMC or Monte Carlo Markov chain over here, which is like giving a math problem to, let's say, 100 people, and then you compare the results of all those 100 people and see if all the answers match up. So if you have the number or the values from each of those 100 people all match up really well, then you are on one over here, and this is the baseline red line over here. And let's say 100 people, 50 of them matched and 50 of them did not, then you're somewhere over here. And if you have values above 1.1, which means it's kind of like everyone's giving different answers, which means you need to investigate a bit more. And that's where you have these kind of distributions where you need to be a bit more careful about and understand what's happening there. But typically, if you're close to the red line, that's perfectly fine. So that's a quick way to read this. But then what do all these parameters mean? There's so many parameters down here, and for each of them, we have the R hat value. So for that, you need to come to the model specification, try to understand this complex looking equation, but I'll break down this equation for you so that it doesn't seem this complicated. But again, if you're in the modeling tab within Meridian documentation, they've done a really great job about explaining all these things and where these come from, like the papers and everything as well. So I've kind of annotated this equation for you so that it's a bit simpler. So all we have to remember is we're calculating the business outcome, and all these parameters over here or these sections, so they're just base performance plus control factors, marketing efforts, and some random noise. So this is basically what we have in this big equation over here. But let's walk through them one by one. So we have this first term over here, mu, which is the overall trend and seasonality within your business, how your business naturally performs over time, and how each geographic region differs from the average as well. So these are the two terms which are also the base performance. So if you don't run any of the ads today, this is what your business will be doing in terms of revenue just based on two. Then you have this term over here, which is the control variables, which can be things like weather, holiday, competitor action, economic indicators. So these are affecting your business, but you can't really control this in your business. So these become your control variables. Similarly, the next term is all the business activities like price change, promotion, product launches. And these are just modeled very similar to how we've modeled the control variable over here, which is without ad stock and saturation. We'll come to what these actually mean in a second. Next, we have a hill ad stock, and this is where we put in your paid media. So activities like TV, social, search, etc. So these are all coming in here. And here we have hill ad stock, and the two primary terms within them are ad stock and saturation, which is up here. So how effects persist over time? So imagine you're running a TV ad, and how long does this effect persist over time? Like how many days do people remember, or how many hours do people remember your ad? That's kind of is an oversimplification of ad stock, and how returns diminish at higher spending levels. So if you're running TV ads, then there must be a point where it kind of plateaus, where even spending billions of dollars might not give you that kind of linear returns. So what is that point? So that is the saturation point. So we use these two terms and then model the paid media channel over here using hill ad stock, and that is what we have here. And we have another hill ad stock over here, and this is for all your organic media channels. This could be the unpaid or organic marketing activity. Then if you remember, Meridian also takes in the reach and frequency. So within your television ad, for example, how many people did you reach? And of all those people, let's say you reached 100 people, how many times did each of those 100 people get to see your ad? Was it 5 times, 10 times? So there is kind of a diminishing return over there. So here all we're doing is taking that reach and frequency. Now, because we have two terms over here, reach and frequency, we kind of do it slightly different. So we know if we keep showing the ads more and more to the same person, then it kind of has a diminished return. So what we do is we first apply the hill function to the frequency. That is what you're seeing here. Then we multiply it by the reach, how many people we've reached, and then finally apply the ad stock, where we want to see how long does this effect persist over time. And we have a similar thing for organic reach and frequency over here as well. And then we have some noise data over here. So that is what we have in this big, huge equation over here. But hopefully I've made it simplified enough so that we can just think of this as base performance, control factors, marketing efforts, and some random noise. And this is what we are optimizing for. And if you come back here, you'll see all these parameters like alpha, beta, and so on, which are also coming in from this equation over here. So if you want, you can tie it back to the charts you're seeing here and see where exactly we're performing well and where we are not. Now, the next set of plots we have here are to look at expected versus actual revenue. So I can just copy this, come back to my notebook and run this as well. So once this runs, you have these three lines over here where you have the expected, which is in the dark blue over here, the actual sales, and the baseline revenue here as well. Now, if you come into the docs, you'll also see a link to model diagnostics. So this is not the only chart you have. So if I open up the model diagnostics, you'll see all the information that we just spoke about, like this R hat convergence. And if I scroll down, you also have access to each of those terms within this R hat and how the ad stock and the saturation kind of affects each of these channels. So again, very, very informative to look at these. And if we keep scrolling down, there's a ton of tables that you can generate here as well. And finally, you have the expected revenue versus actual revenue. So again, we have the expected and the actual sales. So this is the actual revenue. And then the baseline is what would have happened if you did not have any of the marketing activities. So this would be these base terms over here and some of the control variables. So with this command over here, you can also plot for each of the geos. So if I go back to the actual data we had, so you can see here, the second column is the geo column where we have geo 0 and all the way up to like geo 31. I haven't seen the actual bigger numbers than this, but hopefully they're like more geos over here. So all we're doing here is we are plotting the top two largest geos and looking at the expected or the predictive value against the actual value over here. So you can see it's pretty close with this model. It's able to predict the actual sales with each of the geos. So we have geo 10 over here and geo 3. So once you're happy with all these parameters, you can generate a 2-page output out of this MMM model. So we have some handy function, summarizer.summarize, and you can save all that into a Google Drive as well, where you can just put it as a summary output.html, and you can print that exact thing in your notebook using this command as well. So I managed to run through all of this and saved it into my drive. And if I scroll down, you'll see this was the report. So we have some charts like the expected versus actual, and we have the model fit metrics over here. And this is a key chart where we have the channel contribution, and this kind of waterfall chart you'll probably see across all MMM open source tools out there, and open source or closed source doesn't matter. So here we have the baseline sales. So this is looking at all the historical data, and we have organic impression, which is taking up like 6.5% or 86 million in revenue. Then we have some of these paid channels, channel 430, which are also bringing in quite a significant amount of revenue. We have promotion, which is contributing 2.6% to the overall revenue of this business. So just by giving like past 2 years or 3 years worth of data, we're able to get a breakdown of all of these channels and how much revenue they were able to contribute, which is kind of really interesting. And here we just have a percentage of revenue and spend contribution, and we can clearly see that channel 4 over here has a 1.4 contribution, which is also what we're seeing here. It has a bigger contribution to the overall revenue, which is interesting. And we have some pie charts and some return on investment charts over here. These are all really good. So right off the bat, with just one function, you're able to generate a PDF report like this that you can share with your team or your business. So here we have some response curve by the marketing channel. So on the x-axis we have the spend, and on the y we have the incremental outcome over here. So you can see most of them are kind of saturating at some point. This is because of looking at both the ad stock and saturation curves. So you have some more spend that you can put into some of these channels before they kind of saturate. So response curve is actually really interesting to look at, especially if you want to increase spend in one of the channels. And that's about the end of these 2-page reports. Now, just looking at these reports, which are all historical data, it's kind of interesting, but then what can you do about it? How do we take action on this data? And that's where we have the optimization section, where we can use the budget optimizer provided by Meridian and run a budget analysis. So here we are just running through a basic optimize function. And if you run through this, again, it outputs optimization output HTML, which gives you like a sheet like this, and it's telling you the recommended budget allocation. So clearly we see channel 4, which had the highest contribution, shoot up over here, asking us to invest more in this. Channel 3 and 1, not so much, reduce that spend in these channels and then increase over here. So this is a clearly good indication on how we can optimize our budget going forward so that we're able to generate maximum revenue. We have a few more charts here as well, and then we have a table over here, and these are all good. We have some response curve on their own to actually see how much you spend, what are the data points that we have, and also how much on this curve you can spend before reaching that saturation point. So finally, you can come down here to look at the budget optimization links that are given at the bottom of the notebook to understand a bit more about this. And you can finally save your model into a pickle file and then put it in a drive somewhere so that you can come back and run analysis on this model again and again, and you don't have to sit through 14 or 15 minutes just to wait for this model to finish its modeling. So hopefully that gave you enough information to get started on using Meridian on your own. So let me know how it goes, and until then,